Hello, everybody. This video is going to cover operations with exponents. Now, before we go into that, you need to know what an exponent is. It's just a way of writing repeated multiplication. So, for example, if I have 2 to the 4th power, 2 is the base and 4 is the exponent or the power. What this means is that you would multiply 2 by itself this many times, whatever the exponent of the power is. So 2 times 2 times 2 times 2. A really common student mistake when students are first learning this is they think that means 2 times 4, and that's not the case. It's going to be 2 multiplied by itself because it's repeated multiplication. So that base number here gets multiplied by itself this many times. Okay, and 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power is equal to 16. Now I want to show you something kind of interesting here. Here I got my 2 to the 4th power. And we said that's 16. If I went 2 to the 5th power, then what I'm doing is I'm just putting in another 2. So instead of there being 4, there's 5. So what happens really is you take this 16 and you multiply by the base because you're just putting another 2 in there. And this would be 32. So going the opposite direction, you would actually divide by the base, and this would be 8. Now you may be wondering, okay, well that's nice, but why are you showing me that? Because there's certain cases that I want to show you, and I don't want to just say this is the rule, because you need to know why. So this kind of helps explain it. So here, if I went 2 to the 2nd, then you know that's 2 times 2, which is 4, or you could say, well, that's just dividing by 2, right, from the previous one, which we said. But here, this is the first one, 2 to the 1st power. When you divide 4 by 2, you get 2. So that brings up my first rule. Any number raised to the power, excuse my sloppy handwritings because I had coffee, raised to the power 1 is equal to the base. Okay? Next, if I kept going with this, 2 to the 0 then is going to be equal to what? And this is going to be our next rule. Divide by 2 and you get 1. What? That's my second rule. Any number raised to the power 0 is equal to 1. And the reason it is because this relationship here exists no matter what the base is. So if you had 3 to the power 3 and then you went to this 3 to the 2nd and 3 to the 1st and 3 to the 0, this relationship that you see right here would exist, except that you would be dividing by 3, and you would always end up with 3 to the 1st then is going to be equal to 3, or the base 3 to the 0 is going to be equal to 1. If it was x and I said x to the 1st, it's equal to x. And you can think about it like this, because this is repeated multiplication, right? So that's saying 2 multiplied by itself. Well, it's not really saying 1 time. In other words, it's just saying you have just a 2. Because you would need this to have, 2 times 2. Does that make sense? I'm going to use this thing again at a later point, not in this video, to explain what happens if you keep going with this dividing and you have negative exponents, because that's kind of interesting as well. All right, but that's for a later date, my friends. Let's move on. Multiplying numbers with the same base. So, if I have 3 to the 4th, wow, that's a weird 3, and that's a weird 4, times 3 to the 3rd. You got to remember that this first thing means 3 times 3 times 3 times 3. The second one is 3 times 3 times 3. Now remember, if you have parentheses next to each other, that means multiplication. I'm not going to put the x or the dot in between those. Notice that they have the same base. And this is what I'm talking about. The number that's raised to that exponent is the same. Or if it was a variable, it's the same. Well, here, how many 3's do I have? I have 1, 2, 3, 4, 5, 6, 7. So this is 3 to the 7th. Do you see what the rule is, my friend? What is the rule? Can you figure it out? Here it is. If you have the same base, which we have here, this is the same base, you add the exponents. Okay? So, if I had here y to the 7th times y to the 4th, this is going to be what? Just going to be y to the 7 plus 4, which is y to the 11th, because they had the same base. Now, be careful, because I found another common student mistake here is for something like this, 5 to the 2nd times 5. Okay, you got to remember that even though there's no exponent here, it's the same thing as having a 1 because there's a 5 there. Or you could think of it as this is 5 times 5 for that first part, and then times another 5. So when you're doing this, it's 5 to the 3rd power. You got to think of this part here as 5 to the 2nd plus 1. I know it looks like a z, but that's a 2. Let me erase that. Bad. 2 plus 1. Okay? You got to be careful there. And that, by the way, is 125. Oh, look. Antivirus. Very nice. Thank you. All right. Moving on. Dividing numbers with the same base. All right. Here, we got to remember that fraction is the same thing as division. Think of this as a division type problem, right? It's numerator divided by denominator. So, where this is the numerator, the bottom is the denominator. When you have this, you got to think of this. All right, well, let me just write this out first as the repeated multiplication. The top, the numerator is 4 times 4 times 4 times 4 times 4 times 4 times 4. Did I get all the 4s? I think I got all the 4s. And the bottom, there are 5 of them. So it's 4 times 4 times 4 times 4 times 4. Now, hopefully you remember that you could simplify a fraction, numerator and denominator, and when you look at this, you can say, wow, look, this 4 cancels with that one, that one, that one, that one, that one. Whoa, and look at what is left. We have 4 times 4 on the top, and we have just a 1 on the bottom. This is then the same thing as 4 to the 2nd power, or 16. Now, do you see what the rule would be for dividing numbers with the same base? Do you? Hopefully you can say, well, you subtract the exponents. And that is exactly what you would need to do. So, I have this one again, 4 to the 7th over 4 to the 5th. What you would do is 4 to the numerator minus the denominator. You got to do it in that order. So it's numerator minus denominator with the exponents, that is. And this is 4 to the 2nd, which is 16, exactly what we said it would be. So what about this? I have x to the 6th over x to the 2nd. If you want to simplify that, it would be x to the 6 minus 2, which is x. Oops, I just wrote 4. Okay, x to the 4th. Cool? Moving on. Power to a power. Power to the people. Power to a power. This is when you have something like this. So let's say I have 2 to the 3rd power, but I'm raising this whole thing to the 2nd power. That's a power to a power. What this means, let's look at this part first. That means repeated multiplication for everything that's in the parentheses. So what I have is 2 to the 3rd power, and it gets multiplied by itself 2 times. So 2 to the 3rd power, or twice. Okay? And then inside the parentheses, that 2 to the 3rd power means 2 times 2 times 2. And the other one is 2 times 2 times 2. So how many 2's are there? There are 6. There's 2 to the 6th. Now, can you see what the rule is here? Hopefully you said multiply. multiply the exponents. So, for example, the same thing again, 2 to the third times the second, or to the second, means you would take 2 and you would say that 3 times 2. I'm going to multiply those exponents, and this is equal to 2 to the sixth, which is exactly what we said it is. Okay, without having to write all that stuff out. So, try this one. G to the fourth raised to the third. Okay, this is the same thing as G to the fourth times the third, which is G to the 12th. Cool? So there's 3 rules that you need to know here. Now, what I'm going to do is give you some samples, and it's going to mix all this stuff together to see how well you know it. Here I have 5 samples. Okay, what I want you to do for these problems, I want you to pause the video and try to solve these yourself. However, I want you to leave your answer as a number to a power. In other words, don't actually multiply it out in the end. Just try and apply the rules here. Now, a little clue when you get to number 4 is do the fraction first. Okay, so pause the video and try to do these problems. Pause it now! Okay, the first problem, it's same base and it's being multiplied, so we add the exponents. 3 plus 7, this just becomes 5 to the 10th. What? Moving on, the next one. This is also multiplying, but we have this right there. Uh-oh, what does that mean? That means that this second thing, the whole thing is just 1. So this is just 12 to the 9th. See where it comes in handy to know that little rule? All right, to the next one. I have t to the 5th times t to the 4th. Now, anytime there's stuff to do in the numerator or stuff to do in the denominator, do the stuff first before you deal with the fraction itself. So this is t to the 5 plus 4 over t to the 2nd, which is t to the 9th over t to the 2nd, which is t to the 9 minus 2, which is t to the 7th. Now, you don't have to write all those steps. If you kind of can do this mentally, you look over and go, all right, well, that's t to the 9. 9 minus 2 is 7. I get that. But that I want to make sure to show it in case you need to see it. Then here, 4 to the 13 over 4 to the 7 times 4 to the 10th. What? That's very confusing, right? But not if you use the rules. The rules say, well, first of all, I gave you a little clue and said do this thing first, so hopefully you did. So I'm going to do 4 to the 13 minus 7, and then that whole thing will get multiplied by 4 to the 10th. 4 to the 13 minus 7 is 4 to the 6th, and then times 4 to the 10th, which is 4 to the 6 plus 10, or 4 to the 16th power. And then the last one. This one isn't bad unless you didn't realize that the bottom has an exponent of 1. And then 5 minus 1 is 4, so we have f to the 4th power. That is all. Goodbye, my friends. Goodbye.